Alright guys, here I'm going to be showing you how to balance redox reactions in acidic media. So here we have our skeletal reaction that we want to balance. And the first thing that you should notice about this skeletal reaction is that it kind of makes no sense. It's nothing like any other reaction that you've seen before. We have chromium in our reactants, we have chromium in our products, that's normal. We have oxygen in our reactants, but there's no oxygen in our products. So this is a hint to you that something's not quite right, that we're going to have to balance this using the redox method as opposed to just going back and forth and changing coefficients. So there are 7 steps, and I'm going to walk you through each one of them slowly and carefully. So the first step is that you split the reaction into 2 half reactions. Now you kind of just have to make sense with this. This is not really particularly challenging. Let's look at our reactants and let's focus on our chromium containing reactant. So that's going to be a reactant for one of the half reactions. And the product for it is going to be the one that contains chromium. So that's our first half reaction. Then our next half reaction, we have iodide in the reactants, and that goes to form iodine in the products. So that's the first step. Split the reaction into 2 half reactions. Now that we've done that, step number 2 is to balance all of the atoms normally using coefficients except for oxygen and hydrogen. You're going to see that we're going to take care of oxygen and hydrogen in the next step. They're a little bit trickier. They're the differences between normal balancing and balancing redox style. So here we're going to balance atoms, not oxygen or hydrogen, normally using coefficients. So what that means here is we have 2 chromiums in our reactants. Right now we only have 1 chromium in our product, so we're going to put a coefficient of 2 in front of that. So now we've balanced the atoms, not oxygen or hydrogen. So we have 2 chromiums, we have 2 chromiums. Here we have 1 iodine, here we have 2 iodines. So in order to balance that, we put a coefficient of 2 in front of the iodide ion. So now we have balanced all of the atoms, not oxygen or hydrogen. We're leaving them for the next couple steps. Now that we've done that, we're going to balance oxygen atoms with water. Okay, this is a little weird, it's a little tricky, but we're going to balance our oxygen atoms with water molecules. Water molecules have 1 oxygen atom per molecule, so we're going to use water to balance the oxygens. So this is what that looks like. Here's our chromium containing compound. It has 7 oxygen atoms in the reactants. We have 0 oxygen atoms over here in the products. So we're going to have to add in 7 waters. The addition of 7 waters means we had 7 oxygens in the reactants. Now we have 7 oxygens in the products. Again, we're not worrying about hydrogens. Chromiums are balanced. Oxygens are balanced. We'll leave hydrogen to the next step. Our second half reaction, we don't have to worry about that at all because we have no oxygens in our reactants, no oxygens in our products. Now, the next step, step 4, balance, I apologize for this, balance hydrogen atoms with protons. So, what that means, over here we have our chromiums are balanced, our oxygens are balanced, but we have 14 hydrogen atoms in our products over here. In order to balance out those 14 hydrogen atoms, we add 14 protons to the reactant side. And now this is, again, you've heard me say it over and over and over again. You will never not hear me say this. This charge matters. Don't lose that positive charge on the proton. It's going to become very, very important in the next step. So again, we're balancing hydrogen atoms with protons. Double check and make sure everything is making sense at this point. We have 14 hydrogens we have 14 hydrogens, 2 chromiums, 7 oxygens, 7 oxygens. Looking at this half reaction here, we don't have to do anything because we've got no protons on either side. Finally, and this is the hardest step, my students typically struggle with this the most. You have to balance atoms. I apologize again, this is just a bad PowerPoint. You're going to balance the charge with electrons. Now, be careful, electrons have a -1 charge. So we need to keep that in mind. So, let's look at our top one here. Across all of our reactants, we have a plus 14, because we have 14 protons. Each one of those protons has a positive charge. So that's plus 14, and we have a -2. We have 1 chromium ion. That 1 chromium ion has a -2 charge. That means in our reactants, we have overall a plus 12. Let's look at our products. We have 2 chromium 3 ions. So each chromium 3 ion has a 3+ charge. We have 2 of them, so that's a plus 6. And water is neutral, so that's a 0. In our product side, we have a plus 6. We have to get both sides to be the same by the addition of electrons. Now, this is the weird part. You bring down the higher side to meet the lower side. Let me write that down, because again, this is the hardest part for students. Bring down the larger or greater side to match the smaller side. Because again, you're adding electrons, and electrons have a -1 charge. So again, we have a plus 12 in our reactants. We have a plus 6 in our products. We're going to bring down the plus 12 to match the plus 6. And we do that by adding in 6 electrons. Because now 6 electrons is a charge of -6. -6 plus 14, that's plus 8. Plus 8 minus 2 is plus 6. Now our plus 6 is match. So another key, you bring down the larger or greater side to match the smaller side. You should only ever have electrons on one side of a half reaction. And then there's going to be one more final point when we look at that second one. Okay, so looking at our second one here, 2 iodide. Overall, the charge in our reactants is -2. Overall, the charge in our products is 0. You bring down the greater side. The greater side in this case is 0. Bring down the greater side by adding enough electrons to match the lower side. So now that we added in those 2 electrons, 0 minus 2 equals -2. -2 matches -2. So then the next key that you know that you're doing this electron part right is your half reactions. One half reaction should have electrons as a reactant. The other should have the electrons as a product. One half reaction has electrons as reactants. The other has electrons as products. That's how you'll know that you're doing it right. If you get to this point and you've got both of your half reactions there and they both have electrons in the reactants, you've done something wrong and you need to go back and look at all of the other steps. If you've done it right, you should have electrons, and one is the reactants, electrons, and 1 is the products. All right. Step 6, multiply the entire equation by a coefficient to equalize the electrons. So focusing in on the electrons, we have 6 electrons going in our top half reaction. We have 2 electrons coming out in the bottom reaction. I don't have to touch the top reaction. I'm going to multiply that one just by a big old coefficient of 1. But I'm going to multiply the bottom by a coefficient of 3. Multiplying the bottom one by a coefficient of 3 gives me 6 electrons. The whole point that we're trying to get to is the electrons that go in the reactants match the electrons that come out. We're trying to sort of create the cycle. So I'm going to multiply my bottom one by a coefficient of 3. I'm going to rewrite the top one here just so I can have, I'm going to do that in the next slide. Never mind. So I'm going to multiply my bottom half reaction by this coefficient of 3. And that means that everything gets multiplied by that coefficient of 3. So my second half reaction becomes 6 iodides reacts to form 3 iodine plus 6 electron. Double check yourself. You can always double check yourself at any point in time. Everything should equalize. Everything should balance. So what I mean by that is we have 6 I's. We have 6 I's. We have an overall charge of -6. We have an overall charge of -6. All right. Now the last step. We're going to smash them together Hess's law style. So we're going to add these two equations together and cancel appropriately. So Hess's law style, that means whatever is both a reactant and a product can get canceled out. This is the key. 6 electrons in, 6 electrons out. You want to make sure you end with a reaction that has no electrons in it at all. We just use those to help us balance the reaction, not actually go into the equation. So that's the only thing that we have in common. So our balanced reaction now is 14 protons plus 1 chromium ion, chromium containing ion, plus 6 iodides reacts to form 2 chromium 3, 7 water, and 3 iodine. Again, double check to make sure that everything cancels like it should. Everything should balance. Nothing changes. It's just the method on how we get them to balance. So we have 14 hydrogens. We have 7 oxygens. 2 chromium. 6 I's. Overall charge in our reactants, plus 14, minus 2, minus 6, that equals 6. Over here in our products, plus 6, plus 0, plus 0, plus 6. Everything equals and balances as it should.